Down here, the ocean becomes something else entirely. No sunlight, no sound, just endless black water and pressure. At the bottom of the Mariana Trench, nearly 11 kilometers below the surface, the weight of the entire ocean presses down with unimaginable force. The pressure here is more than 1,000 times stronger than at sea level. That's enough force to crush steel like a soda can. If a normal submarine tried to descend this deep, its metal hull would collapse instantly. Not slowly, not gradually. In a fraction of a second, the entire vessel would implode. Water would rush inward faster than a human eye can blink. Everything inside would be destroyed instantly. So how could any machine possibly survive down there? The answer begins with a submarine unlike anything ever built. A deep-sea research vessel engineered to withstand one of the most hostile environments on Earth. A machine that cost nearly $100 million to build. Its name is the Abyss Hunter, and every part of it is designed for one purpose: to survive the crushing darkness at the bottom of the ocean. Inside a massive engineering hangar, this extraordinary submarine begins as raw metal. Not ordinary steel, but grade 5 titanium. Titanium is one of the strongest structural materials on Earth. It is lighter than steel, resistant to corrosion, and capable of surviving enormous pressure. Engineers cut the thick titanium plates with robotic precision. Every millimeter matters. Even the smallest structural flaw could mean catastrophic failure thousands of meters underwater. Robotic welding arms fuse the titanium components together. Sparks fly through the dark factory air as the skeleton of the submarine slowly takes shape. Above the construction floor, computer simulations constantly analyze the structure. Advanced software predicts how the hull will behave under extreme ocean pressure. Stress maps glow across digital blueprints. Every curve, every weld, every bolt location is calculated, because at 11,000 meters below the surface, mistakes are not allowed. At the heart of the submarine lies its most important component, a perfectly shaped titanium sphere. This sphere is the crew capsule, the place where human explorers will sit during the descent into the abyss. The spherical shape is not chosen by accident. It is the strongest geometry possible under external pressure. When the crushing weight of the ocean pushes from every direction, a sphere distributes the force evenly across its surface. No corners, no weak points, just pure structural strength. The titanium walls of this sphere are incredibly thick. Several centimeters of solid metal separate the crew from the most extreme pressure environment on the planet. Engineers inspect the capsule carefully. Scanning devices measure microscopic variations in the metal surface. Even a tiny crack could grow under pressure. And deep underwater, a crack means disaster. To understand the forces involved, imagine this. Stack dozens of cargo trucks on top of a single soda can. Now multiply that weight thousands of times. That's roughly the pressure experienced at the bottom of the Mariana Trench. In laboratory demonstrations, engineers show what happens under such force. A simple aluminum can collapses instantly, crushed into a flat disc. That is the same kind of pressure the submarine must survive. But the crew still needs a way to see outside, so the engineers install something extraordinary: a thick sapphire observation window. Sapphire is one of the hardest transparent materials on Earth. The window is carefully lowered into the titanium hull. Massive bolts seal it into place. If anything fails here, the ocean will rush in with unstoppable
Look at this reading
force.
on the joint integrity.
Before the submarine ever touches
That's
the
higher
real
than
ocean,
expected.
it must pass
Let's
a
rescan the
brutal
lower
test
quadrant.
inside a gigantic pressure chamber. The titanium capsule is lowered into a massive tank filled with water. Sensors cover the surface of the hull. Cables measure every microscopic deformation. Slowly, the pressure begins to rise. Inside the chamber, the water churns and swirls as powerful pumps simulate the crushing force of the deep ocean. Steel test blocks nearby begin to bend under the pressure, but the titanium sphere holds. The sensors report the stress across the hull. Engineers watch the monitors closely. If anything looks wrong, the test stops immediately, but the structure remains stable, exactly as designed. Once the pressure capsule is approved, the rest of the submarine begins to take shape around it. A protective composite frame is lowered into position. This outer structure holds the propulsion system, the scientific instruments, and the external equipment. Next comes the power system. Rows of advanced lithium battery modules slide into place along the submarine's interior frame. These batteries provide the energy needed for long, deep-sea missions. Cooling pipes circulate liquid through the battery packs. Without cooling, the batteries could overheat. Fiber optic cables carry data between hundreds of onboard sensors. Inside the electrical panels, hundreds of colored wires connect the submarine's complex systems. Navigation computers, communication systems, life support equipment. Every component must work flawlessly in the most remote environment on Earth. Then comes the propulsion system. Four powerful magnetic thrusters are mounted at the rear of the submarine.
Locked in place,
Inside each
Doctor.
thruster,
Powering up
copper
the sensor
coils
array.
generate strong electromagnetic fields. These fields spin the rotor blades with incredible efficiency. When activated underwater, the thrusters create powerful vortices that push the submarine forward. Engineers test them inside large water tanks. High-speed cameras monitor the flow patterns behind the spinning blades. On the control monitors, efficiency graphs and power readings update in real time. The propulsion system must be powerful enough to maneuver in deep ocean currents, yet precise enough to hover above the seafloor. At the front of the submarine, scientific equipment begins to appear. A massive 8K deep-sea camera is mounted inside a pressure-resistant housing. This camera will capture images of a world that almost no human has ever seen. Nearby, a multi-joint robotic arm unfolds from its storage mount. Its claw can gently pick up tiny sediment samples from the ocean floor, or retrieve biological specimens from deep-sea ecosystems. Sonar arrays line the hull. They emit pulses of sound into the darkness. These pulses bounce back from underwater terrain, allowing computers to build detailed 3D maps of the seafloor. In front of the submarine, powerful LED lights are installed. When activated, they will cut through the blackness of the deep ocean like searchlights. With every system installed, the Abyss Hunter finally stands complete. A compact but incredibly sophisticated machine. But before its first mission, engineers simulate the most dangerous scenario: hull failure. Computer models show what would happen if the structure cracked under pressure. A microscopic fracture forms. The stress spreads rapidly, and in less than a second, the entire structure collapses inward. An implosion. Violent,
The sphere collapses
instant,
in milliseconds.
irreversible.
A violent vacuum
The comparison
compared to the
is
relative
shocking.
eternity of a
The
single
collapse
human
happens
eye blink.
faster than a human blink. That is why every component of the submarine must be built perfectly, because deep in the ocean there are no second chances. Finally, the real submarine returns to the test floor. Sensors confirm that the titanium sphere remains structurally sound. Engineers review the final data. All systems are green. Inside the cockpit, the interior glows with soft blue lighting. Holographic displays flicker to life. Navigation systems load the mission profile. A three-dimensional map of the Mariana Trench appears on the central screen. Target depth, 10,935 meters. The deepest place in the ocean. A gloved hand flips the heavy metal control switches. Life support systems activate. Battery levels are full. Thrusters ready. Sensors calibrated. Mission status ready. The massive hangar doors slowly open. Bright sunlight floods into the dark industrial space. Outside, the open ocean waits. A heavy transport platform carries the submarine toward the launch crane at the dock. Soon, the Abyss Hunter will begin its descent. Down through kilometers of cold black water, toward a place where the pressure could crush almost anything ever built. But this machine was designed for that exact challenge, because at the bottom of the Mariana Trench, only the strongest technology on Earth can survive.